Hello students, today's topic is predicate calculus. In this video, we will discuss about predicates and quantifiers, statement functions, free and bound variables. Okay, what is meant by predicate? Predicates and quantifiers. Consider the statement x is greater than 3. Okay. Now this statement has two parts. First part is the variable x. The variable x. This is called subject of the statement. Subject of the statement. The second part. What is the second part? Is greater than 3. Is greater than 3. This is called predicate. This is called predicate. It refers to a property that the subject can have. That the subject of the statement can have. Okay, that means predicate means a property that the subject of the statement can have. Okay, you can denote the statement x is greater than 3. X is greater than 3. You can denote this statement by p of x. P of x, where p is predicate. P is the predicate. What is that? Is greater than 3. Okay. You can denote this statement by P of x, where P is predicate. Okay. Now, we also say P of x is the value of P of x is also said to be the value of the propositional function. Propositional function p at x. Once a value has been assigned to the variable x, then p of x becomes a proposition. And p of x is a proposition. That means it is true or false. That means it has a truth value. Okay. See an example. Let p of x denote the statement. Denote the statement x greater than 3. What are the truth values of? What are the truth values of P of 2 and P of 4? See the solution. What is P of x here? P of x. That is the statement x greater than. P of x is x greater than 3. So now, what is P of 2? P of 2 is the statement 2 greater than 3, which is false. Is false. And hence, P of 2 has truth value. What is its truth value? Truth value f. Okay, since it is false. Okay. Now P of 4. P of 4 is the statement 4 greater than 3, which is true. And hence its truth value is truth value is t. Okay, see the next example. Let q of xy denote the statement x equal to y plus 3. What are the truth values of q of 1 2 and q of 3 0? See the solution. What is the given statement? Q of xy is x equal to y plus 3. Now what is q of 1 2? Q of 1 2, that is the statement 1 equal to 2 plus 3. 1 equal to 2 plus 3. This is false. Which is false. And hence its truth value is f. Its truth value is f. Okay. Next, q of 3 0. This is the statement 3 equal to 0 plus 3. X equal to y plus 3. That means 3 equal to y is 0. 0 plus 3. This is true. Okay. Which is true. And hence its truth value is t. Is t. Next definition, statement function. Definition. A simple statement function is an expression consisting of a predicate symbol and an individual variable. Okay, simple statement function means that is an expression consisting of predicate symbol and an individual variable. For example, p of x, q of x. Okay, these are simple statement functions. Now, what are compound statement functions? Compound statement functions. Compound statement functions. These are obtained by combining two or more simple statement functions and logical connectives. Okay, are obtained by combining two or more simple statement functions and logical connectives. Logical connectives. Connectives means and, or, implies, by implies. Okay. For example of compound statement functions, m of x and h of x. Suppose m of x and h of x are two simple statement functions. M of x and h of x is a compound statement function. M of x implies h of x. M of x or negation of h of x. These are all examples of compound statement functions. Next, quantifiers. There are two types of quantifiers. First one, universal quantifiers. Second one, existential quantifiers. universal quantifiers and existential quantifiers. Next definition. Universal quantification of P of x. Okay? The universal quantification of a statement P of x. The universal quantification of a statement P of x is the proposition P of x is true. P of x is true for all values of x in the universe of discourse. In the universe of discourse. Universe of discourse means domain. Okay. Now, universal quantification of x, P of x is true for all values of x in the universe of discourse. We can denote this by for all x, P of x. For all x, P of x. Okay. This is the universal quantification of P of x. Here the symbol for all is called universal quantifier. Universal quantifier. For all x, P of x. We read this as for all x, P of x, or for every x, P of x. Okay, this is universal quantification of P of x. Okay, see an example. Let P of x denote the statement x plus 1 greater than x. Then what is the truth value of universal quantification? What is that? For all x, P of x, where the universe of discourse consists of all real numbers. Consists of all real numbers. Okay, here P of x is x plus 1 greater than x. Now I have to find the truth value of the universal quantification for all x, P of x. See this. P of x is given x plus 1 greater than x. For any value of x, this is true. Okay, since P of x is true for every real number x, for every real number x, the universal quantification for all x, P of x is true. Okay, since this statement is true for any x. Okay, and hence the universal quantification for all x, P of x is true, and hence its truth value is t. Okay, next example. What is the truth value of the universal quantification for all x, P of x, where P of x is the statement x square less than 10 and the universe of discourse is consists of all positive integers not exceeding 4. Okay. Here P of x is x square less than 10. We have to find the truth value of the universal quantification for all x, P of x. Okay. Now P of x is x square less than 10. Okay. Now since the universe of discourse, what is the universe of discourse? 1, 2, 3, 4. Since that is set of all positive integers not exceeding 4, that is 1, 2, 3, 4. Okay, and hence for all x, P of x is of the form, the conjunction P of 1 and P of 2 and P of 3 and P of 4. Okay? You can write the universal quantification for all x P of x as this conjunction. Okay? And since P of 4, what is P of 4? That is 4 square less than 10, which is false. Which is false. And hence this conjunction becomes false. Okay? Therefore, the universal quantification for all x P of x is false. Okay. Next definition. The existential quantification. Existential quantification of a statement P of x is the proposition there exists an element x in the universe of discourse, such that P of x is true. P of x is true. Okay? This is the existential quantification of P of x. That means that is the proposition there exists an element x in the universe of discourse such that P of x is true. Okay? The existential quantification is denoted by there exists x P of x. There exists x P of x. Okay? Here there exists is called existential quantifier. Existential quantifier. Okay. The existential quantification of P of x is read as there is an x such that P of x, or there exists an element x such that P of x, or for some x P of x. Okay, see an example. Let P of x denote the statement x greater than 3. Then what is the truth value of there exists x P of x. That means this is the existential quantifier. Okay, where the universe of discourse consists of all real numbers. Okay, we have to find the truth value of the existential quantification. There exists x P of x. So this given P of x is the statement x greater than 3. This is true for some x. For some x, since for instance consider P of 4, that is 4 greater than 3, which is true. Okay, which is true. That means there exists an element x such that P of x is true, and hence the existential quantification there exists x P of x is true. Okay, see the next example. Let Q of x denote the statement x equal to x plus 1. What is the truth value of there exists x Q of x? That means existential quantification. Okay, where the universe of discourse consists of all real numbers. Of all real numbers. Okay. See the solution. Given the statement q of x is x equal to x plus 1. This is false for every value of x in real numbers. Okay. Which is false. The statement is false for every real number x. Okay, and hence the existential quantifier, there exists x, q of x is false. Since there exists no element such that this statement is true, and hence the existential quantification is false. Okay. Next definition, free and bound variables. Free and bound variables. Okay. See the definition. Let D be a set. D be a set. If for each x in D, if for each x in D, P of x is a proposition. That means P of x is true or false. Okay. Then P of x is called predicate or propositional function. Propositional function. Okay. P of x is called predicate function or propositional function. Here D is called domain of discourse. Domain of discourse. And x is called free variable. X is called free variable. Understand? Next definition. The variable appearing in for all x, p of x, or there exists x, p of x, is called bound variable. Is called bound variable. That means when a quantifier is used on the variable, that is called bound variable. Or when we have to assign a value to the variable to get a proposition, that is called bound variable. Okay. Now, if p of xy is a sentence, then in for all x, p of xy, only the variable x is bounded. Okay. Okay, students. Thank you so much for watching. See you in the next video.